Guys, today I'm with another video, and yeah, it's much more stupid than you think. So let's understand what's the value of 2 times x squared. Now can you tell me what it will mean? Now what some people will do, they will just multiply the 2 times 2 and the x with x and get 4x cube. It's a very smart way. It's a very really keenly smart way. But what structurally or in the structure it actually forms. So let us first break it. So when you break it, we get, or let's unsimplify this whole term. We get x times. Look here, we use brackets because the two x terms times x times x. Now we get this. Now you may tell me why we get brackets inside it. Why we use the brackets? We use the brackets because the x plus x and x minus x times xy terms were used or simplified first, because after simplifying x plus x you get 2x. That's what it means. Like when you have 2 times x times this thing was firstly simplified, so when you unsimplified you give the brackets. That's what it means. First simplify, then multiply with the 2 or x squared or x times x. Okay, so yeah, we have to use brackets when you unsimplify such terms in such expressions. Now it's equals, now let's multiply with the 2 times x squared, like with the x plus x with the 2. Now you get x plus x times plus x plus x times x times x. Now you may ask why we got the x, why we got the second bracket. We got the second bracket because of multiplying with the 2x terms with x plus x first. Because when you have 2 times x plus x, it essentially means x plus x bracketed plus x plus x. Or when you suppose, let's take a simple one, 2 times 2x means 2x plus 2x, right? Now 2x plus 2x is 4x. Why x plus x plus x plus x. Now why the x plus x were like, let's just first finish it. Now we get the second bracket because of multiplying it with the first two, right? Now let me show you by simplifying it. So when you have bracketed this thing over here, so let's first simplify inside the first bracket. So we get 2x plus 2x. Now when you got that, I'm just simplifying the bracketed x plus x plus bracketed x plus x, which is also second bracketed and multiplied with 2. That means first add x plus x and again there add x plus x and add those two x plus x plus x plus x. After adding x plus x, like do the first thing in the bracket, so you get 2x. Now 2x plus 2x is same as writing 2 times 2x, right? Look, we just return back into the 2 times. So That's why we just use bracket. It's just representing that we just multiply the 2 times 2x with the x plus x term. Nothing more than this. Is just representing that we just multiply the 2x first, and as we are just doing it in its unsimplified form, we aren't simplifying, so we are just doing in its raw structure. That's why it happens. When you multiply any operation, that's what actually underneath happens. So now what we do, we distribute the x times x in x plus x, because sum of something doesn't actually gets distributed, because x times x actually gives, x times x is itself is a constant. Okay, because x times x means x squared. Now if you don't simplify x times x, now look, if you have x times x multiplied with x plus x, or suppose you have a times b multiplied with c times c plus d. Okay, remember, the a times b will get distributed in c plus d, because multiplication always gets distributed in addition, whatever it is. Suppose you have 3 times 2 times 4. Now this 3 times 2 times 4 will always get, and times 4 times 2. Now this 3 times 2 times 4 always will be, every single multiplication gets distributed over addition. Okay, let's do it now. Now distribute the x times x with in the x plus x, and within the second bracket first we get, after distribution the brackets always get off, like you always will see that after distribution the brackets get off, as it's already the answer. Okay, it's already the answer, we already multiplied, so why we need brackets? So now you can write it as x plus x times x x plus plus x plus x times x times x. Okay, now again we distribute the x times x in x plus x, because a sum, a, a multiplication a multiplication a multiplication of something always gets distributed in a sum, but a sum doesn't get distributed in a multiplication, because yeah, that's what it is. Like suppose you have 3 times 2 times a plus b, and a plus b is bracketed. Yeah, after adding a plus b you multiply with 3 times 2, then the 3 times 2, this whole thing will get distributed in a plus b, as a plus b was added 3 times 2 times. Okay, again let me explain you. When you have 3 times 2 times a plus b, okay, whole numbers, I'm talking about whole numbers, ratios are different case. Now in case of whole numbers, when you have 3 times 2 times a plus b, it can be rewritten as, like, as a plus b was added 3 times 2, or 6 times, so the whole 3 times 2 will get distributed up whole of multiplication gets distributed in addition, but addition doesn't get distributed in multiplication. It's a very common sense. Now so we distribute, as a result we distribute the x times x in x plus x, so we get x times x times x plus x times x x. Now look, here is our final answer. Look, here is our final answer. A simple overview. So what you would get, it's equals to this, equals to 4x cube, right? 4x cube, right? Now look, there is 4x cube. Look, x times x, so x times x is x squared, and x squared times x is x cube. Common sense. As look, when you have a bracket in same operation, suppose you have 3 times 2 times 4, all are multiplication, and if there is a bracket, you can get rid of the bracket. You cannot care about the brackets, because in case of multiplication order doesn't matter. But if there is a bracket in division, it matters, because division is not like you can swap places. Okay, division, division order actually matters. Order actually matters, because each division means each things. Okay, in this thing the order really does matter. Okay, the order does really matter here. So yeah, so first we multiplied the first we unsimplified all the terms, then we played the operation in their unsimplified terms, and after that we got their final result in unsimplified form. Now if we just simplify it, we got a result. So when you try to understand, if you try to understand any equation, you first have to unsimplify their all 2x or their simplified terms. Like x cube is a simplified term, because it means x times x times x. After doing all of this, you get x cubed. It's a simplified terms. It's not like a normal value. It's a simplified. You always have to simplify such expressions like 2x, x squared, 2x squared, or any types of like this such terms. I think you got the terms like 2x, x is just x, so there's nothing to break. So 2x or anything multiplied with x, like 3x, 4x, 5x, 6x, like 6x is like 6 times x, or 6 times x is actually multiplied before, something like this. If you get something like this, you always have to unsimplify those terms first to get what actually the equation means, then play those operations in their unsimplified form, and you will get the result in unsimplified form. And if you just simplify the result in unsimplified form, like simplify the unsimplified result, you will get the same result. And those thinking is actually just a clever way thinking, but it's actually understanding the original structure.